Before we dive in, let's learn the two key terms you'll hear constantly, operator and operand. In the simple expression 5 plus 10, the plus symbol is the operator, the action we're performing. The values it acts upon, 5 and 10, are the operands. Every operation you'll see, no matter how complex, is built from this simple structure. With that terminology clear, let's look at our roadmap. Python groups its operators into logical categories. We'll begin with the familiar arithmetic operators for math, then move to assignment for storing values, comparison for asking questions, and logical for combining those questions. We'll finish with the more advanced identity and membership operators. First up, let's do some math. Arithmetic operators are the calculator in your code. The most basic are addition, using the plus symbol, and subtraction, using the minus symbol. They work on numbers and variables exactly as you'd expect, forming the basis of countless calculations, from totaling a shopping cart to calculating a game score. Next, we have multiplication, represented by an asterisk. It multiplies numbers together, which is essential for things like calculating prices based on quantity. But this operator has a clever second ability we'll explore right after this. Here's that special trick. When used with a string and an integer, the multiplication operator doesn't do math. It performs repetition. It repeats the string a specified number of times. This is a fantastic Pythonic shortcut for creating separators, borders, or initializing simple patterns. When it comes to division, Python offers 3 distinct tools for precise control over your results. This is more powerful than a simple calculator. We have true division, floor division, and the modulo operator. First, let's look at true division, which is likely the one you're most familiar with. True division, using a single // works just like a standard calculator. It performs the division and always returns a floating point number, a number with a decimal point, even if the division results in a whole number. This ensures mathematical precision. But what if you don't want the decimal part? For that, we use floor division with a double /. It performs the division and then rounds the result down to the nearest whole number, effectively chopping off the remainder. This is perfect for problems like figuring out how many full boxes you can pack. We've seen how to get the whole number result, but what about getting just the remainder? That's the job of our third division tool, the modulus operator, represented by a %sign. It gives you what's left over after a division, which is incredibly useful for a variety of programming tasks. The modulus operator might seem abstract, but it's a programmer's secret weapon. Its most common use is checking for divisibility. If a number modulo another number is 0, it means it's perfectly divisible. This is how we can easily check if a number is even or odd, by checking if it's divisible by 2. Our final arithmetic operator is exponentiation, which raises a number to a power. Using a double asterisk, you can easily calculate squares, cubes, or even find roots. For example, 2 ** 3 is not 2 times 3, but 2 raised to the power of 3. Great! We can now perform any calculation we want. But a result is useless if we can't save it. That's the job of our next category, assignment operators. The most fundamental is the simple equal sign. In Python, it doesn't mean is equal to. It's an action that says store the value on the right into the variable on the left. This brings us to one of the most common mistakes for beginners, confusing the assignment operator, a single equals, with the equality comparison operator, which uses 2 equal signs. Let's make this crystal clear. 1 equals is a command, 2 equals is a question. Very often in programming, you need to modify a variable's existing value. For example, to add 10 to a score. The long way is to write score equals score plus 10. This works, but Python provides a cleaner, more efficient shorthand called compound assignment operators. The most common is plus equals. This convenient shorthand isn't just for addition. It exists for all the other arithmetic operators too. You can use minus equals to subtract and assign, multiply equals to multiply and assign, and so on. They all follow the same pattern. Perform the operation, then update the original variable in one clean step. Now that we can do math and store values, it's time to give our programs a brain. We need to ask questions and make decisions. This is the job of comparison operators. Instead of a number, they return one of two answers, true or false. These special values are called Booleans, and they are the foundation of all logic. We've already addressed the common pitfall of equal versus equal equal. The equal to operator, equal equal, is our first comparison tool. It asks the question, do these two operands have the same value? The answer will always be true or false. The opposite of this is not equal to, written with an exclamation mark and an equal sign. Beyond equality, we often need to compare magnitudes. Python uses the familiar greater than, and less than symbols from mathematics. These are essential for checking if a value falls within a certain range, like checking if a temperature is above freezing or a score is below the passing grade. But what if you want to include the boundary value in your check? For example, is a score of 50 greater than or equal to the passing grade of 50? For this, we have greater than and less than. They work just like their counterparts, but return true if the values are also equal. Now that we can ask simple true-false questions, how do we combine them to create more complex rules? That's where logical operators, and, or, and not come in. They are the glue that allows us to build sophisticated decision-making logic from our simple comparison building blocks. The AND operator is the strictest. It only returns true if every single condition it connects is true. If even one condition is false, the entire expression becomes false. Think of it as a secure login system. You need the correct username and the correct password. The OR operator is more lenient. It returns true if at least one of the conditions it connects is true. It only returns false if all conditions are false. This is like a special offer that applies if you have a coupon or you're a club member. You don't need to be both. Finally, the NOT operator is the simplest. It's a unary operator, meaning it only acts on one operand, and its job is to flip the Boolean value. It turns true into false and false into true. It's like asking, is the door not locked? Now for a uniquely Pythonic and readable set of operators. Membership operators. In and not in check for presence. They ask, is this value found inside this sequence? The sequence can be a list, a string, or other collection types. They make your code read almost like plain English. Our next category, identity operators, touches on how Python manages memory. While equal equal checks if two variables have the same value, the is operator checks if they refer to the exact same object. This is like asking if two people have the same name versus asking if they are the very same person. Let's see this crucial difference with an example using lists. If we create two separate lists that happen to contain the same elements, the equals operator will say they are equal. But because they are two distinct objects in memory, the is operator will say they are not identical. This is a critical concept for avoiding subtle bugs. With all these operators, how does Python know which one to perform first? In the expression 2 plus 3 times 4, is the answer 20 or 14? Python follows a strict order of operations known as operator precedence. Just like in math class, some operators are more powerful and get to go first. Python's precedence hierarchy is logical. At the top are parentheses, which always go first. Then comes exponentiation. After that are multiplication and division, which have equal precedence. Then come addition and subtraction. This is why 2 plus 3 times 4 is 14, because multiplication has higher precedence than addition. If you ever need to override that default order, or if you just want to make your code clearer, you have the ultimate tool, parentheses. Any expression inside parentheses is evaluated first no matter what. Using them liberally is a great habit, as it removes all ambiguity and makes your logic easy to follow. Congratulations! You've journeyed through the entire landscape of Python's essential operators. From simple arithmetic to complex logical combinations, you now have the foundational tools to build robust program logic, control your code's flow, and make intelligent decisions based on data. Let's see it all come together in a practical example, a simple validator for a user comment. Our rules are: the comment must not be empty, must be under 100 characters, and must not contain any forbidden words. This requires combining multiple operator types to enforce our logic. Here's the code. We assign the user's input to a variable. Then, we use a single if statement that combines our rules. We use comparison operators to check the length, the not in membership operator to check for forbidden words, and the and logical operator to ensure all conditions are met. See how they work together to create one powerful piece of logic. You now have a complete and powerful understanding of Python's operators. From the humble plus sign to the nuanced is operator, these are the tools you will use every single day as a programmer. Keep practicing, experiment with combining them, and soon using them to build complex logic will become second nature. Happy coding!